Srishti, are my slides visible?
Yes,
Okay,
ma'am.
thank you. So, good evening, everyone. I am Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTEL, whose course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputre from ISER Pune. So, in this last week and week 8, we are going to cover problems based on rearrangement and named reactions. So, in last class, I have given this question as homework. So, let's try. So, here they are asking about major product. These are your options available. First of all, let's draw structure of this reagent, right? Correct. So, Srishti, you tell me what is role of this base here? Potassium tert butoxide. First step, according to you, what should be its first step? Don't you think it will abstract proton from alpha carbon and then it will form carbanion that is going to attack here, right? Only possibility here is this.
Yes.
Yes, right? So let's draw one by one and see what can be our product. So we will get here pH O negative and from here this carbon ion. Okay, here carbon ion will form and CO280, CO280. Right now, till here any problem?
No.
Okay. Now let's see ahead. In third step, it is giving workup. Now first see if it can attack here. So let's count first. One, two, three, four, five. Yes, it can form ring here. It is going to attack in intramolecular fashion. You draw in your copy, you will get it. Correct? Correct or not?
Yes.
Now this is going to come here and which bond will break now? This bond can break, right?
OECD.
Yes.
O8.
We are just looking at possibilities. What possibilities are there? So it will form your CO280 1, 2, 3, 4, 5. Correct. But we can see that in all these options, no option is carrying this. Correct.
Yes.
So now can you tell me what is your next idea? What can we do here? You can think from this intermediate. Let me redraw here. Now take some time and think what other possibility is there. So Shrishti,
No idea.
huh,
No.
no issue. So Srishti, you can see there is one more acidic proton, right? We have base in our medium. This that base is going to abstract proton from here. Here carbon ion will come. That will open this, correct? And what we will get? We uh, we will write it pH only. pH, C, pH, and here what we are forming? Wait, pH, pH, double bond, CO280, and COOO negative. And that last step, what is given? Work up, HClH 3O positive. Actually, it's H3O positive. Okay, so it will become acid. Now tell me in which option it is there. Option number 4, right? Because in option number 4, 2 pH are there, and here also 2 pH are there, CO2ET and CH2COH. Uh, do you know
Then
what?
in first option also there are two pH.
Very good. First option there are 2 pH, but they are separated, right? In our product which we got, they are on same carbon if you see.
Okay, sis. Okay.
Okay. And another thing is that I was asking, do you know what name reaction is this? So let me tell you, this is stops condensation. This is from last class problem session. Okay, so let me give you explanation again. Okay, first base is going to abstract. Let me use that pointer. Hmm. First, this is your strong base. This is going to abstract proton from here. Okay, it will attack this ketone. After attacking, this O negative will form 5-member ring by intramolecular attack on this ester. Okay, then at last this acidic hydrogen is going to deprotonate by base, and it will open this 5-member ring and will result into formation of this acid. Clear? Okay.
Yes.
So this is problem number 2. Which carbonyl compound is the main product of the following reaction of a diol? So this is a diol. Given conditions are H2SO4 H2. Can you name this reaction just by looking at it? If you can't name, no issue. Can you just tell me what will be the first step?
Pinacol on
Very good,
rearrangement.
very good. It's pinacolone rearrangement. First let me write pinacolone rearrangement. Good. So here we are having acidic conditions, correct? Now tell me, we are having alcohol in our system, acidic medium is there. First step will be, just try, no issue if you are wrong, just try. First step is protonation of any of.
Protonation.
Yes, very good. So
Acid.
tell me which hydroxyl you are going to proton. Let me number this hydroxyl matlab OH number 1 or OH number 2.
OH1.
Two.
Reason.
More stable carbocation will be formed after removal of
Very good,
water.
very good. Who is answering this? Shrushti only?
No, ma'am. Suman.
Okay, other students have also joined. Let me see so that I can take their name. Okay, Suman, Shrushti. Good. You all are going to solve. Okay, I'm only here to write. Very good, Suman. So, in pinacolone rearrangement, first protonate that hydroxyl, which is going to give you more stable carbocation. Okay. Next step, can anyone tell me?
Migration of methyl group.
Migration of methyl group. Reason behind that? Because
With
incoming
carbocation
carbocation will be mesomerically stabilized by
stabilized by the OH group.
OH group. Very good. Mesomerically stabilized by this OH group. So you are saying methyl group will migrate. So methyl will come here. Sorry for that. So methyl will come here, correct? If some students have problem how it is migrating, let me explain in simple language. See, here carbocation is here, or we can say that plus charge is here. So it will migrate in negative form. So when it will form in negative form, here it will left positive charge, correct? And that negative is going to attack here. Understood, everyone?
Yes, ma'am.
Yes, good. In last step, nothing is there. It is going to, what we can say that decrease or stabilize this positive charge by this mesomeric effect. Okay. And at last, after hydrolysis, we will get here ketone. So, so tell me fast which option this product is there. COCH3 in option number D. Correct? Any problem in this solution? Take your time and tell me.
No, ma'am.
Okay. So
No,
let
ma'am.
so let's move ahead. Do you know name reaction involving this? This is same reaction as before, but name reaction is different. Since in this week 8, sir talked about various name reaction, so I am focusing here on name also. Okay. So can anyone tell me what name reaction is this? Let me give you a hint. Name starts from D. So students,
Imagine a
very good. So students, whenever you have leaving group is that NH2, we all very well know that in presence of NaNO2 HCl, it is going to form your diazonium salt. Correct? Okay. So if you have looked at it, basically in this reaction, what happened? One of the group become leaving group and another group becomes mesomerically stabilizing group. Correct? Here, what was the leaving group? H2O molecule. Understood now how H2O molecule leave? It is going to protonate here, here, and it will leave as H2O. Correct, students? So in same way here, N2 positive will move. So she correct. So this is name reaction. So you are going to solve or I solve? If you have solved, can you tell me correct answer? So we have two students in our class, Rushti. and Suman. Options. I am also solving, you guys also solve and tell me the correct answer. And try to solve before me. Can anyone tell?
Option D.
Option D. Option D, Suman or Srishti? Suman, I think.
Yes, ma'am.
Okay. So just tell me next step. Here it will form carbocation, correct? Now just you have to do anything which can bring positive charge on this carbon, correct? So just break any of the two bond, either this one or this one. So if we break this bond, just keep carbon as it is, give them charge. Oh, sorry for that. Give here negative charge. Here OH was there and CH3 positive, correct? And just join these charges and give number for simplification. 1, 2, 3, 4, 5, 6. Correct na? Yes. So draw 6-member ring. On first number carbon, CH3 is there. On second number carbon, positive charge is there with hydroxyl group. On third, fourth as it is, fifth, sixth as attacked. At last we got in these type of cases ketone, CH3 and double bond O. So yes, very good Suman. Correct answer is D. Understood na everyone?
Yes, ma'am.
Okay. So let's move to problem number 4, which is the main product of following reaction of an amide. You have this amide. Given conditions are Br2 NaOH H2. Just tell me name reaction just by looking at it.
Hoffman rearrangement.
Very good. But better you call it Hoffman
Hoffman
bromamide
bromide
degradation, right?
reaction.
But you are correct. There is going to take place Hoffman rearrangement. Now, can anyone remind your 12th class textbook, and can anyone tell me how many equivalent of sodium hydroxide we take in that balanced reaction? Anyone remember Br2 plus 4 NaOH? Famous J question. How many moles of sodium hydroxide you take? Correct. So this was only for GK. So let's see its mechanism. And please you start solving, okay? And tell me before I solve. So if you are not solving, just tell me first step. In first step, what will happen?
NH2 proton will be abstracted by base.
Very good, very good. CH3, CH2, CO, NH negative. And you know that Br2 is given. So it will attack here, correct? And what it will form? CH3, CH2, CO, NH, Br. Or here what will liberate? HBr. Now tell me next. Base is there, and I have told you here. First base has been utilized, correct? Now it's turn up of second base. It will again abstract proton, correct? So it will form, oh sorry, CH3, CH2, CO, NH, and that it will Br. Okay, so let's say it has undergone reson. Let's draw its resonating structure. CH3, CH2, O negative, double bond N, Br. This is just its resonating structure. Now next step, tell me students, CH3, CH2, CO, nitrine formation. Okay, now let me tell you what is nitrine formation. See, whenever you have nitrogen, whenever you are having negative charge on nitrogen atom and a leaving group is attached to it, leaving group will go in negative form, correct? What charge it will leave here? Positive. And when any atom is having positive charge, dual character, it is carbene. If it is on carbon, it is known as carbene. If it is on nitrogen, it is known as nitrine. So, so basically, it is equivalent to this. So funda is clear. Nitrine funda. Okay. So now you should know how this rearrangement takes place. Okay. So let's assume, students, let's assume that, as I have said, there are two charges. Wherever you have problem, stop me, okay, and ask. Let's assume this negative charge is going there. CH3, CH2, CO negative, double bond N, and you very well know that positive charge will leave here. Keep, because of dual nature of charges here, one of the charges, this I am explaining just for your simplicity, okay? That nitrine behave like this, one positive charge and one negative charge. Now see, when this O negative charge will come back, this group actually migrates here. So what you will get here?
Isocyanate.
Very good. Isocyanate. CH3, CH2, N, double bond, C, double bond O. Till here, anyone have any problem? Nothing has been done, just this alkyl group has migrated there. Correct?
Ma'am, you are not audible to me.
Now,
Yes, ma'am.
other students, I'm audible.
Yes, now,
Okay.
now you are audible, but before you are not audible.
Okay, okay. Sorry, students. Just tell me wherever. Let me check. So, students, just looking at Hoffman bromamide degradation, what option you will choose at first instant?
Option B.
Option B. And how it is going to form? Now you know that you have 4 moles of base. Again, it will abstract proton from here and it will leave as CO2, correct? And after hydrolysis, you will get CH3, CH2, NH2 plus CO2. Any problem?
No, ma'am.
Sure, na? Okay. So let me rub this and let's see exact mechanism. It is not. Actually, eraser is not working there. Okay, you can see later this mechanism. See here also they have used KOH, NOH, any base you can use. Okay, so we have formed this N-bromamide, correct? And then isocyanate formation take place. That OH is going to attack on this carbonyl, and at last intramolecular proton transfer, and that CO2 will leave. I will erase this in last, and you can see the mechanism. Okay. So coming to problem number 5, which alkene is the main product of acid catalyzed dehydration of the following alcohol? Students, I am audible, right? Student,
Yes, yes, ma'am.
okay. I thought again I have disconnected. So they are saying the reaction may involve a rearrangement. Okay. So can anyone tell me that rearrangement name? Okay, forget about name. Just tell me stability order of carbocations.
Tertiary is
Tertiary is
more
more
stable than
stable.
Very
secondary is
good.
more stable.
Tertiary, secondary, primary. Okay. So first step, you we all know that OH is going to protonate. Correct. And it will leave as leaving group, leaving behind famous species, that is our carbocation. Now, two possibilities are there. It can take hydride from this. Will it take? Is there any benefit of taking hydride from here? So it will undergo 1,2 methyl shift. I am correct or wrong? Just tell me, students. Correct. Here, can anyone tell me how many hyperconjugation was there in structure, or we can say that intermediate A? Do you know how to calculate hyperconjugation? Do you know what is
Mm.
hyperconjugation?
Yes, yes,
Okay,
ma'am.
just now tell me. Okay, for others, let me tell you number of alpha hydrogens. Alpha means just next carbon attached to that intermediate, that charge. This is alpha carbon, this is alpha carbon. So in structure A, it is having two hyperconjugation. And in structure B, how many hyperconjugation? 3, 3 and 1. How much? 7 hyperconjugation. Correct, na?
Yes, ma'am.
So it is obvious that it is most stable carbocation. So now your work is done almost. You just now nothing is given else other than this. See, whenever you have formed this carbocation, now there is two possibility. If nucleophile is there, just attach there. If nothing is given, final possibility is elimination. Correct. So elimination can take place from this carbon, but you know that by Sedgwick rule, most substituted alkene will form. Correct. So this is your major product. In which option it is there? Option number B. Correct. Or any CH3, 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 and one CH2, CH3. All of you, and you have understood now this problem.
Yes, ma'am.
As I was talking about name, these types of rearrangements are known as Wegener. At end of the class, I am going to ask every name reaction. So please be with me here. To each student, I am going to ask what is this name reaction? What is this? Okay, good. This is again pinacolone rearrangement. I am expecting from you to solve this question as I have discussed this question just before some time. So let me read for you. Which is the main product of the following rearrangement of a bicyclic diode? So first step, please help me in solving. Unmute yourself and tell me steps. Sorry for this.
Protonation of alcohol.
Very good. Protonation. You have to what I will say, you have to do rearrangement until your carbocation gets maximum stabilization. Okay. Here it will come OH positive. Carbocation will form. Now what will now next step will be bond breaking, correct? Students, correct na? Bond breaking will take place and it positive charge will come here, negative will come here. See, you don't have to draw this structure in your exam. In exam, you have to draw like this. Okay. This means positive charge will come here, negative will come here, and that negative is going to join there. For this, you can do in your rough to get better understanding. Now, just you have to form these two bonds. And how many member ring will form? One, two, three, four, five. So just let's draw. Have I drawn correctly?
Yes, ma'am.
Now tell me, will further rearrangement take place or not?
No, ma'am.
Why?
It is mesomerically
Very
stable.
good, very good.
Carboform.
This I want to listen. Why it is not getting further shifted? Because mesomeric effect is most pronounced. You should remember, for carbocation stability, first you have to see mesomeric effect. Then order wise, you have to see aromaticity. Then you have to see resonance. Then hyperconjugation. Always see carbocation stability in this order. You will never do wrong. And at last, inductive effect. So I am going to ask fastly. Just tell me, in mesomeric, plus M is going to give benefit to carbocation or minus M? Plus M or minus M?
Plus
Plus M.
M.
Plus M. Plus M are those groups which are heteroatoms which are having lone pair, which can donate their lone pair. Okay. Aromaticity, you very well know that if you have system like this system is also stable. Why? Strained also, but then also it is stable due to aromaticity. 4n plus 2 pi electron, and due to positive charge, all carbon are sp2, correct? So this is also stable. Resonance, you very well know that if it is allylic, correct? Hyperconjugation, you just have to calculate number of alpha hydrogens. More the hydrogens, more is your hyperconjugation and more is your stability. And in inductive, plus I groups, correct? So which option is correct, students?
Option A.
Option D.
Option B.
Option A.
Option A,
Sorry,
student.
option A.
Hmm.
Sorry,
I
option
know
A.
you got confused. No issue. Okay, because carbonyl is on five member ring system. So this is most appropriate answer. Good. You know now how to solve? So problem number 7. Can anyone tell me, after seeing reaction condition, Which reaction condition it looks like? Let me give you hint. Um, in case of phenol, we study this type of reaction, and
Yes,
Dimer reaction.
Riemann-Tiemann reaction.
reaction.
And which intermediate is involved in this? Among carbene and
Carbene.
carbene. So you all know that first step is your simple formation of carbene. How it will form? First, base is going to abstract your proton. You have three chlorine. One of the chlorine will go, and I have told you earlier also, when there is any leaving group here, it will form positive negative. Positive, why? Because Cl minus has left. So here you got carbene. Good. But students, if you remember, in case of OH, correct, oxygen lone pair was coming back and it is attacking to that carbene. Okay, tell me, carbene is electrophilic or nucleophilic?
It's an electrophile.
Electrophile. Why? Because carbene is 6 electron species. Correct. So students, here here you were having that OH pushed electron density here, that is attacking on this carbon. Can anyone tell me in this case what is going to happen? Okay, hint is, you have told only that this is electrophilic. So tell me which is most electron rich double bond among these three double bonds.
Middle one.
Middle one. Okay. So we will see possibility only. Okay. Okay. If someone is thinking that base is going to abstract proton from here, since it is carbon ion, matlab, since it is aromatic system, it is stabilized, and you are going to directly attack this. And what charge will remain here? Negative, correct? But you can see, no option is there in which 5 member ring is there, correct? So it means carbene will show its another reaction. Carbene has another function also, it insertion in double bond. If you have double bond and if you have carbene, it directly forms this. For sake of your simplicity, just break it in positive negative. You know your carbene is also positive negative. So just join opposite polarity and it will form this 3 member ring. Understood?
Yes, ma'am.
Okay. So in same way we are going to, so it will form this. Now next step, think now.
Ring opening.
One thing I have done wrong. This is not Cl. This is carbon with two chlorine. Let me draw big structure. Very good, ring opening. But how it will take place? Okay, I'm giving you hint. Now base is there. Base can abstract proton from here, correct? Base will come here. Now among these two, this bond and this bond, which is going to break among 1 and 2? See, in your options all are 6 membered rings. So for forming 6 membered ring, Which bond is going to break? Here double bond will come. This bond is shifting here, so double bond. Correct? Correct or not? As it was joined there, as it is I have formed. Wait, students. Let me erase this part. Just draw in your copy and tell me the most appropriate answer. This is chocolate question. Most difficult question from carbon which can come in your exams. Level will not go above this. This I have taken from JEE Advanced previous year questions. So we are having this. But since this double bond has been utilized in this cyclopropanation, I will say, and negative charge is here. So I was saying that this will come here, this will come here. Now which bond is going to break? So let's say this bond has been broken. Okay. So you will get structure like, correct students still here, but one mistake is there. Double bond will come here and this double bond has shifted here. Correct? So just count 1, 2, 3, 4, 5, 6. 6 member ring is there. Okay. And your second carbon is having Cl, and from 1 and third carbon 1, 2 dash, 3 dash, 4 dash, and this 5. Is this type of system stable, students? Yes or no?
No.
No. So it means I'm going from starting, student, so that you know how to tackle a problem. In organic you should know, you should draw all the possible products. I have broken this bond and made this product and we found out that this is not possible. Now which bond you can break?
Bond number 2.
Bond number 2. And what type of structure you will get? Tell me. Till then let me erase this part. Okay. Just break those double bond and you will get to know. Negative here charge. So it, and bond number 2 was, I have broken this bond. Now just break this. We are doing mistake anywhere.
Yes, it is going reverse.
Yes.
Reverse.
Yes, you're right. Negative charge will come here. Okay. Now bond will break positive negative. Either this bond can break or this bond can break. Okay, we will see this question at the end of the session. Okay, just remind me we have to do this problem 7. So this is your Remer-Temin reaction. I have kept here mechanism. As you all know, first base is going to abstract proton, will result into formation of this carb anion. We have phenol also. In phenol, in basic medium, it will form phenolate ion. Phenolate ion is going to attack your carbene and will result into formation of this molecule. What is the common molecule of product? Common name of this product?
Salicylaldehyde.
Very good. So problem number 8. By looking at this intermediate, can anyone instantly tell me intermediate involved in this reaction? Your options are carbene, nitrene, benzene. Heat is given.
Nitrine.
Nitrene. Exactly. Why? Because N3 we can write in this form, N2 write like this. Oh, sorry. Uh, Negative, positive. Here zero charge. We can write it in this form, correct? So after exclusion of N2, you know that wherever possible, this type of exclusion, it is entropically driven reaction. Nitrene will form, correct? And here you are having NH2. Now what will form? After nitrene, and if you are having carbonyl group just adjacent to nitrene, what it will form? Isocyanate. Remember in Hoffman bromamide we have formed that isocyanate. Or I explain again here. Students,
Yes, ma'am.
explain again or it is understood here?
Oh,
Okay. So it is going to attack here how many 1, 2, 3, 4, 5 membered ring will form. Now intramolecular proton transfer will take place. Intramolecular proton transfer. Other students, I'm going fast. You can tell me. I will slow down. It will form OH, NH, and at last tautomerism will take place. And which option you will get? Option number A. Correct or not?
yes, ma'am.
So option number A is correct. So again, if we see solution of this, first in heating condition nitrene has been formed. Whenever you are having carbonyl group adjacent to your nitrene, you have to form isocyanate, and then isocyanate you have to attack from any nucleophile. Okay, anyone of you have this doubt why I am breaking this bond only among these two, N double bond C and double bond O? Why not this N double bond C?
Can you repeat the question?
Okay, my question is why I am breaking this C double bond O? Why not C double bond N? Means positive charge will come here and negative here like this. N C. Why I am not doing this? Why always?
Oxygen is more electronegative.
Very
Oxygen bonds on oxygen atom.
exactly, because oxygen is your more electronegative. So always whenever any nucleophile is given, you have to break this bond. Correct. So nitrene type question you have to deal in this way. Just form nitrene, form isocyanate, a nucleophile attack. Finish. Correct. So this is your problem number 9. By looking at starting material which is oxime in acidic condition, what will What are your products possible? Name reaction. Fast, students. What name reaction is involved in this reaction?
Bachmann rearrangement.
Bachmann rearrangement. Very good. If you know name of reaction, I hope you know mechanism also. So just tell me products. Take half. Okay. Take 1 minute, and you guys solve and tell me how to solve this. Okay. Let me give you starting hint. Since acidic media is there, it is going to protonate oxime hydroxyl group, means OH. Now some migration will take, or we can say that rearrangement will take place. So tell me product. Take 1 minute, and if you're not able to solve, tell me.
Ma'am, option C.
Option C.
It's
Who is
option.
answering this?
Ma'am, me.
Tell me your name. Actually, I can't see your names.
Harshita.
Okay, Harshita is saying option number C. And Suman, Srushti,
It's C, ma'am.
Suman is saying also. Then though I think C is correct if two students are saying. Any other options? No, na? So let's see. CH3 C double bond N. I am writing in most simplified way. But see, this positive charge not get formed. This is instantaneous. You are getting my point, right? Simultaneously, this group leaves, and that whatever migrating group is going to come on this nitrogen, it will come and this leave. This positive charge I am forming here for your simplicity. Now, what will happen? Okay, in option number A,
H3 will migrate.
which group will migrate, methyl or pH?
Methyl.
Methyl. Why? Because it is anti, anti to
And
your hydroxyl group. Okay.
I-
So if this group will migrate, what charge will come? If CH3 group migrates, positive charge will come. Correct or not?
yes, ma'am.
Yes. Now,
Attack of water molecule.
attack of water molecule. Okay. Now, CO, pH, N, CH3. So you were saying C, CH3, NH, Very good. And here, since only these two group have swapped, so this product will come. But in exam, you have to show like this. Let me draw that correct version. So option number C is correct. Very good, students. If I draw it that way, CH3NOH, CH3 is trans, correct? And lone pair is here, pH. See, first H2SO4 is there, so just draw in this way. OH, H, positive, CH3, pH. Correct? This group will just draw this in this way, okay? Don't form carbocation here. Sorry, that will not be carbocation, but don't form positive charge directly here. It is rearrangement type concerted reaction. Correct? And further to you can draw. I'm clear to all or not?
Yes,
Yes,
ma'am.
ma'am.
Okay, okay. Okay, so more than one correct answer. This is chocolate question of today's session. Okay, select the correct Bayer vinegar oxidation reaction. Okay, can anyone tell me what is the common name of this reagent? MC.
Paracet.
So sorry. This is not MCPBA, but for Bayer vinegar oxidation,
Paracet.
we use MCPBOs. Full form meta
Metachloroperoxybenzoic acid.
wrong. Sorry, metachloroperoxy नहीं, पर benzoic acid.
Okay.
Metachloro per benzoic acid. If I draw its structure, metachloro per one oxygen is extra. So, can anyone tell me among these two oxygen, which is nucleophilic? Okay, what is proximal oxygen is here and what is distal oxygen? Proximal is which is nearest and distal is which is, so this is your distal carbon, this is your proximal carbon. You should know that nomenclature. Okay. So first tell me in this reaction, you all know that oxygen get inserted, correct? To which side it inserted? Do you know order?
Distal oxygen. Oxygen number 2 will be inserted.
No. That is your correct answer. I'm asking to which side oxygen will get inserted. Either this
And
left
on
side
the
or
carbonyl carbon.
could you please repeat?
On the carbonyl carbon it attacks.
No.
Nucleophilic
Let
oxygen.
me explain my question again. Let's say you have this. Okay. You know that after MCPBA or whatever this oxidizing agent, you will get either this product or your this product. Among A and B, which is major product? I'm asking this. To which side your oxygen will insert? You know that order
On ethyl.
on
Ethyl will be
on
ethyl will
ethyl.
be preferred.
Why? You know, first, if you look at migratory aptitude, first T-butyl will come, then your pH, then your 2 degree, then your 1 degree. Correct, students?
Yes, ma'am.
Okay. So in first you will get caprolactone. Yeah, it is correct. Caprolactone, you know na? This is your caprolactone. Correct? Six member ring was there. After insertion of one oxygen, it will become seven member. So you will get this product. So option number A. Oh, wait. You were going to tell me answer, na? Tell me. Which two options are sorry? Which two need more than one correct answer is there? So which options are correct? Tell me answer by first telling your name.
A and B.
A and B. I think Suman is
Yes,
telling this.
ma'am.
Na? So A and B. Okay. Another uh, other girl name Harshita, I think, and Sushti. Tell me your
Ma'am,
answer.
A and D.
A and D. Who is telling?
Ma'am, me Harshita.
A and D. Okay. Srishti, how many students are there in class? Let me check. Okay. Srishti has left, I think. Okay. So Suman is saying option number A and B. Obviously, A is right as you have discussed. So in B, correct beer vinegar oxidation. Um, Among these two group, which where oxygen will come? Since I have told you T-butyl group has more better migratory aptitude, so oxygen will insert here, Harshita. Okay, so option B is correct. Among these two options, this is wrong, and you should know among H and pH, your H has better migratory aptitude. So it will form this. Students, aldehyde is more prone to oxidation. Okay. So correct answers are option number A and B. Very good, Sumi. And very good, Harshita.
Ma'am,
For tell me.
ma'am, when we talk about benzene, it will stabilize it through resonance effect. And tertiary butyl will stabilize the transition state by inductive effect. And we know that resonance effect is more stronger than inductive effect. Then why tertiary butyl is more migratory in
Okay,
this reaction?
okay, let me answer your query. If you have attended Sir's lecture, he has told there is not proper answer to this reason. This order has come from experimental results. First experiments were performed with T-butyl, pH 2 degree, and then they have found out that among these two, T-butyl group is is having more migratory aptitude. You are correct. We see first by resonance, then inductive. But here, only in bare vinegar oxidation, this order we will follow. But let's say if we are having a carbocation question, that Wagner-Nervin rearrangement types question, there pH will come ahead, then T-butyl, then 2 degree, then 1 degree. Okay, this outcome we got from experimental results. Correct? Understood?
Okay, ma'am.
So you have to here memorize actually. Just memorize. T butyl will come first, then your pH, then 2 degree, then 1 degree. Let's put H here. Now correct. You all know mechanism of this, or I should tell mechanism also. Okay, if you know mechanism, can anyone tell me which type of transition state get formed here?
Concerted type of transition
Concerted,
state.
but there is name for that.
No, I don't know.
Why eraser is not working? Okay, let me draw from here. Um, Correct. You have your this paracet. Let me name this R. Okay, for simplicity purpose. So RCOOH. I have told you this is your nucleophilic oxygen. So this is going to attack here. O negative, O H positive, O CO R. Now next, so you know that IMPTR, intramolecular proton trans. Here OH will come and here it will go. Correct? Correct, students?
Yes, ma'am.
Actually, eraser is not working. Now it is working. Let me draw. Let me live. Now there are two possibility. Either this wait, oxygen lone pair will come back and one of the group will migrate to this oxygen, and it will leave as this as whatever acetate ion will leave. Okay, so among these two, let's say here we are having methyl and here we are having hydrogen. Correct. So momentarily, which charge is coming here, students? Here, sorry. Okay, forget that. Oxygen lone pair will come here and one of the group migrates. If oxygen charge will come here, it will be positive, correct, and will form carbonyl again. And here negative charge will come. That will attach to your oxygen, that group, and this will leave. I hope you got mechanism. what I want to convey here.
Yes, ma'am.
Okay, so let's come to next question. The reaction that gives E, okay, E2 methyl hex 3-ene as the major product. You know na EZ nomenclature, how to give this EZ nomenclature?
Yes, ma'am.
Okay. Do you all know Peterson olefination? If not, I will first tell you Peterson olefination, then we will come to this question.
Don't know, ma'am.
Don't know. This type of olefination, Julia olefination. Actually, it is modified Julia olefination. So first, look at mechanism of Peterson olefination. So students, in Peterson olefination, look from here, okay, from second line. You have alpha, beta hydroxysilane. Okay, your starting material is beta, hydroxysilane. There are two conditions for Peterson olefination. One is your acidic condition, one is your basic condition. Okay, in basic condition, your OH base is going to abstract proton from here. Okay, and you know that silicon have vacant orbitals, so it is going to attack there, and it will form four-member ring. Understood till here? And at last, your olefin will form like this. Silicon oxygen bond will form, and you will get your olefin. Understood, students? But in acidic medium, first OH will get protonated and it will leave. And you all know that beta silyl carbocations are beta silane alpha beta. Beta silyl carbocation are stabilized. And in acidic medium, your TMS group and your OH group should be anti. TMS and OH group should be anti to each other. Like in E2 elimination. E2 elimination, what condition is required for elimination? That your hydrogen and your leaving group should be anti-periplanar to each other. In the same way, in acidic condition, they should be anti, and in basic medium, they should be on same side so that four-member ring can form, and it will result into formation of this elimination. Have you understood, students? Yes or no? If you have
Yes, ma'am.
any doubt, you can ask. So coming to problem number 11, if you know now Peterson olefination, tell me answer. First is your Peterson olefination, second is your Witty, third is your simple Wagner-Merwin rearrangement, and fourth is your modified Julia olefination. Okay. So you should know, student, this is your Lewis acid. In acidic media, your OH and SiMe3 should be syn or anti?
And
Anti.
anti.
Anti. Correct? But here they are syn. So obviously, whatever product will form will come cis to each other. I know you see. Here in starting material, for basic reaction condition, they should be syn. Okay, so double bond which has formed is as per starting material. In starting they are trans, and in product also they are trans. One is that side, one is this side. Okay, but we know that in acidic media they should be anti to each other. So for anti, this bond will, let me explain you in simple language. Wait, SME3 is there, R is there, R is here, OH is here, and one other is your hydrogen. Correct. You know that for acidic condition, this SiMe3 and this OH should be anti. Correct. So we have to, as per stereochemistry, keeping one bond fixed, we can align all three bonds. Correct. In that order, OH will come down. Now, can anyone tell me on wedge what will come and on dash what will come? We can rotate three bonds, correct? Stereo will remain same. Now what should I write on this wedge?
R.
R. Okay. And here H. Now they have become, no, sorry. Here
We have
hydrogen
written
will
opposite.
come. You have to interchange all these groups. OH will come here. Okay. R will come there. If you imagine, R is coming, R is towards you, hydrogen is going away from you, and OH is above. Okay, so on interchanging, they will replace each other. Correct. So since you know that now they have become anti to each other, so just form olefin, and you know that R and R are on same side, same matlab, cis cis. So just draw them cis. You know what I want to you understood what I want to convey from here. Just look at here. In this transition state, are they in proper orientation? Yes, they are same. So just draw them same in olefin also. Understood how I am giving stereochemistry here?
Yes, ma'am.
Just draw in your copy, you will get. So now tell me, in option number A, we will get E alkene or Z alkene?
Z alkene.
Z alkene. Um, Here let me put H, isopropyl. Correct, students? Because in acidic media, your silane and OH group should be anti to each other, but here they were same to each other. Okay, in B, what type of alkene you will get? Okay, tell me, this is stabilized ylide or unstabilized ylide? Remember, students, in Wittig, okay, Wittig, first your ylide forms PPH3 positive, Br negative. Base is there, it will abstract proton from here. Whenever you have having carbon ion attached to any heteroatom which is having positive charge, it is known as ylide. Okay, now see, carbon ion is forming here. If this R group is stabilizing your carbon ion, it will come under stabilized ylide. If this R group is not stabilized, it will come under unstabilized. You know, alkyl groups are not going to stabilize your carbon ion, so they will come under unstabilized ylide. Here what group will come? NO2, CN, CHO. Understood, students? Stabilized
Yes,
halides and unstabilized halide.
sir.
Good. Now you just remember in stabilized halide, E alkene forms, and in unstabilized halide, Z alkene forms. Okay. So here, just tell me fast. In option number three, it is stabilized halide or unstabilized halide?
Unstable.
Unstable. Why? Because this is alkyl group. Okay, students. So it will give you. Oh, sorry. So it will give you. And what is formation of Wittig? What is product of Wittig? Just in place of carbonyl, you have to put olefin, and here you are having two substituents. One is H and another is isopropyl. So IPR here and H will come here. Understood? So this is your Z alkene, but they want E. You know that in option number 2 positive charge will form, and it can give both product E and Z, mixture of two products. So correct option is your D. This is Julia olefination, and this is your homework. Draw mechanism for this olefination. Students, this is your last lecture, but I am going to take one more lecture on 15th. Around 2 p.m. you are free or not?
Yes, ma'am.
There I will give you summary of all the lectures in all the 8 weeks, starting from electrophilic aromatic substitution, nucleophilic aromatic substitution, and whatever carbonyl compound, name reaction. We will have brief summary there. I will just ask oral questions, and we'll
Could
put
it be
some problem.
later
What?
in the evening? Could it be in evening
Actually,
in spite of 2 p.m.?
um, okay, I will request them. If they will say me yes, I will put that class in evening. Otherwise, you will get recording. But I will feel more good if you come in live class.
Oh, okay, ma'am. Okay.
Okay. So in that class, till that class, draw mechanism of Julia olefination. In Julia olefination, I will give you hint. LiHMDS is your base. Lithium hexamethyl disilazide. Lithium hexamethyl disilazide. Okay, we will. So this is your base, and base is going to abstract proton from this. Correct? On abstracting this proton, just attack on this aldehyde and start and try to form product. Okay. Let me tell you, in Julia olefination also you will get your alkene only, but just draw mechanism till that class. Okay, I have give you hint. You just have to abstract proton from here and attack on that carbonyl. Correct? Let me draw correct structure of LiHMDS. That is, okay, students. Anyone know about LDA? What is LDA?
Lithium diisopropylamine.
uh, LDA, lithium. Very good, you know lithium. This lithium diisopropyl amide. We call it lithium diisopropyl amide. Okay. This is also a lithium. These are actually bulky bases. Their work is to just abstract a proton. They are non-nucleophilic bases. They can't act as nucleophile. They have only one function, that is abstraction of proton. So this is your lithium hexamethyl lithium hexamethyl disilazide. Okay. Peterson olefination we have covered. Just draw again these two. You will get what I was conveying. Okay. If we all know that in basic condition this should be syn, they are syn. So in starting if they are trans, so in product also they will be trans. But in acidic condition they should be anti. This silane and this OH. So in starting they are trans, so in product they will be syn. Why ulta? Because their requirement is not as per convention. As per convention they should be anti. So for anti they will move, and after moving stereo will change. Here they are trans, here they will become cis. Understood? Okay. This can I give you as homework? This is question from Wagner Mervin rearrangement. Okay. Just anyone tell me first step of this reaction, then you are all set to go. First step,
Protonation of oxygen.
protonation. Protonation and then ring expansion. Correct. So, can I skip this question?
Yes, ma'am.
Okay. Oh, don't say answer, please. Okay. Problem number 13. This is your reaction sequence. You have to tell product C of reaction. First, Suman. Suman, tell me in first step what will form? I will draw.
Ox- Oxime will be
Oxime.
formed.
Very good. You will get oxime. Double bond NOH. Correct? This is your A. In second step, Harshita, what H plus is there? H plus is any acidic source like H2SO4. What reaction condition is this? Beckmann rearrangement. Correct? Correct or
Yes,
not?
ma'am.
Okay. So after Beckmann rearrangement, what it will form? Correct? This caprolactam type species, if I draw it correctly, this, and after LAH. LAH, anyone know full form of LAH?
Lithium aluminum hydride.
Very good, very good. Lithium. What is what it is reducing agent or oxidizing agent?
Fusing agent.
Okay.
Reducing
So tell
agent.
me the final product if you know everything.
Option C.
Option number C. How it will form option number C, students? See, you are saying
Option D.
option. Okay, you speak,
Sorry,
Suman.
sorry. D.
Option
D.
D.
Option D. Any
D.
other
D is the right.
answer? Okay, amide on reduction with lithium aluminum hydride. They form hydroxylamine or amine. Just revise your concept, students. Suman, your answer was? Okay, I am deleting this option number A and C. Option number B and D, tell me.
I'm confused if there will be elimination of water molecule, then B will be formed.
Think about this. Okay, what is first role of LAH?
Hydride transfer.
Hydride transfer to what?
Oxygen to nitrogen.
See, if we
To carbonyl
if
carbon.
we draw structure of your lithium aluminum hydride, it is like this, correct?
Hmm.
In this form, it is very eager to protonate, correct? But here, in this case, it is in amide case actually. In amide case, actually it undergoes deprotonation. Okay, deprotonation from here. This this complex actually takes proton from here, and what it will form? CH3CO NH negative. Correct? Correct or not? And then it will form CH3 C double bond NH O negative Li positive. Students, still here clear? And
Yes,
yes,
ma'am.
and you know that now you are having ALH3 also in media. It will actually, we have another molecule of amide also, correct? So that will form ALH3 also. So here O negative will again attack here. This is from boron family, and whenever boron family compounds having three bonds, it they will be electron deficient, and it will form CH3 CO Al H 3. Again it will form negative charge since it has formed four bonds. Correct? Till here there is any doubt or not?
No, ma'am.
Correct na?
Okay, madam.
Now this group will leave, and then it will form imine. CH3 C double bond NH2 positive. It will form imine, and your hydride will come and reduce this. So always remember, amide on reduction with LAH, amide on reduction with LAH forms amine. Okay, instead of forming that this one, this is also possible, but you should know in amide case reaction goes like this, and it will form amine. So most appropriate answer is B. Correct, students?
Yes, ma'am.
Okay. So give me answer of this problem number 14. First step is cyanohydrin.
Nucleophilic addition.
Very good. That is cyanohydrin formation. Correct. On LAH, students, fast. On LAH, CH2NH2. Correct. On NaNO2 HCl, I'm going fast, students. You can tell me. If I'm going fast, I will slow down. On NaNO2 HCl, what it will form now? Tell me.
Diazonium.
Diazonium means leaving group. Now, which type of question it has formed? Question,
Like pinacol. Pinacol.
question number third of today's problem session. It has formed Demsonov rearrangement.
Pinacol.
Here positive charge will come. Remember, this group will migrate. So which option is correct? Option number A. Understood na? For that another student, I think he has joined late. Let me explain you from again basic. And that CH2 positive will come since we on breaking this bond we can get more stable carbocation, that is mesomerically stabilized. Here negative charge will come, CH2 positive, that will join, and at last you will get cyclohexanone. Understood, student?
Yes, ma'am.
Okay. So this is last question of today's problem solving session. Just tell me. This is again your Demjanov rearrangement, but here stereo I want to see. See, in Demjanov rearrangement also, students, your leaving group should be anti wait, let me tell from here. Your migrating group and your leaving group should be anti to each other, anti form. Okay. So if we look at cyclohexane, let's say you are having this NH2OH. They are anti to each other. So this is very good formation. And let's say here after diazotization N2 positive will come. Here positive will come. So directly oxygen will come and it will form your epoxide. Correct? But here in this problem, they are not anti. They're anti, but they are not anti-periplanar. Why anti? This is down, this is up. They are anti, good, but they are not periplanar. They should be exactly at 180 degree to each other. Understood? I am audible now, students. You are not giving any response.
Yes, ma'am.
Okay.
Yes.
So, can any student tell me which which group is anti to this bond? Which bond is actually anti to this bond?
Carbon carbon homo
Huh.
bond.
But which, let me use color coding here and then you can tell. Will this green bond migrate or will this, sorry, I have drawn this also green, or will this blue bond migrate?
Green
Green.
one.
Why?
Ma'am, this diazonium is sp hybridized. It is linear, so its sigma plus LUMO orbital will get better overlap with that
No,
bond.
that is good. But if we look at it, this is also anti to this. Okay, this is also anti, yeah. See, because we know that it can mesomerically stabilize. So this bond is going to attack here. So how are going to draw? Just for simplicity, negative charge will come here. Okay, here positive charge as N2 due to exclusion of N2, positive, and this is going to form this 5 member ring. Students, you are understanding now here what I am doing.
Yes,
Yes,
ma'am.
ma'am.
So, which option is correct? Cyclopentane carboxyaldehyde means this
Should be.
CHO. Understood? So, whenever this type of actually this type of questions are there in your assignment also. Okay, NPTEL. So always remember, whenever they are in like this form, you have to form this 5 member ring with aldehyde, and whenever they are whenever they are in axial position, you have to form epoxide. Let me write, axial position में हो तो you have to form epoxide, and if they are equatorial anti तो होने ही चाहिए most condition, and equatorial हो तो you have to draw 5 member. Understood now how I am doing?
Yes,
Yes, ma'am.
ma'am.
Okay. So any doubt? Now we have left one question there. This is your homework. Okay. We will discuss this question in that summary session. Okay. And students, I will try my best to postpone that class in evening. If not, I will just request you to join class at 2 p.m. Okay. On 15th Tuesday. Otherwise, you will get recording. This question we also left. So students, just try this question by forming carbonyl here. Or another you can try is you can do from here, that CClCl. Okay. Just try and come up with solution. This is okay, sorry. This also I am giving as homework. So these two questions are homework. Okay. I will expect you to do these questions in next class. Now Let's have a quick recap of today's name reaction. Can you tell me all the name reactions we have discussed today? At least five.
Wegener, Mervyn,
Wagner-Mervin rearrangement,
Demijanov,
Dengenov,
Pinacolon,
Pinacolon,
Hoffman rearrangement.
Hoffman rearrangement, and first question, stops condensation. Correct?
That I have not done. I have joined on second question.
Okay. No issue. Okay, everyone is clear na? Harshita, Kasturi, Suman.
Yes, ma'am.
Okay.
Yes, ma'am.
So I will request you to join class on 15. Okay.
Okay, ma'am.
Thank you for joining the class. Okay, you can leave now.
Thank you, ma'am.